Page 16 of quadratics. Page 16 really builds on page 15 with slightly more complex and difficult problems. We looked on page 15 at problems where we had a red parabola and we had a blue tangent line or a cutting line or a not touching line, and we discovered that if you set the red equation equal to the blue equation, if you set their y's equal to each other, then you can solve for the x, which is going to tell you where this intersection point is. And another thing is, when you combine the red and the blue together, the red quadratic with the blue line, when you set them equal to each other and move all the numbers to the left and then leave 0 on the right, you end up with another quadratic. Let's say it's a purple quadratic, which is different than these two, and the purple quadratic crosses the x-axis at the points that the red and the blue intersect. So, like for example, if I take the red equation, set it equal to the blue equation, and then I simplify it into a purple equation, which is going to be a parabola also, but a different parabola. This parabola happens to touch the it touches the x-axis at the same x value that the red and the blue touch each other. Okay, so just keep that in mind. That's going to help us because you know, if for example this purple one is just touching the x-axis, then we know that the discriminant is equal to 0, right? So we can use that fact to figure out exactly what this purple equation looks like, or what the red equation looks like, or what the blue equation looks like. If you didn't understand what I was talking about, that's okay. I'm introducing this problem, and maybe if we really do the problem, then you're going to understand. So here I have a red quadratic, and I have a blue line. Okay? Notice something strange about this blue line. The m is a constant, an unknown number, so we don't exactly know what the equation of m of the blue line is, and they're going to actually ask us for the exact equation. They're going to ask us, what is m? Okay? The clue they're going to give us is that the red parabola and the blue line are tangents. Okay? So like the blue line is a tangent to the red quadratic, so exactly as it's drawn here. That's the situation here. The blue line exactly touches the red quadratic at one point. So they're saying, what does m have to be so that they touch each other in this way? Okay? So we do it the exact same way we've done it up until now, which is we take the red quadratic and put it on the left-hand side. We take the blue line and we put it on the right-hand side. So let's do that. We put x squared minus 4x plus 2. And then the right side is going to be mx minus 2. We can set them equal to each other because we're assuming we're finding the intersection points, and the intersection points have common y's and they have common x's, so the orange x's are all the same, the pink y's are all the same if they indeed intersect. Okay, so now I'm going to combine these in a purple equation. I'm going to subtract mx and plus 2 from both sides. And then I'm going to get x squared minus 4x minus mx plus 4. And then the right side becomes 0, right? Because mx minus mx is 0. Negative 2 plus 2 is equal to 0, right? So now I have a quadratic here. And I'm going to combine the 4 and the m together. Okay, and then I'm going to add 4 here. Okay, so now I have a purple quadratic, and I know from my description before that for the red and the blue to be tangent to each other, the purple quadratic has to have a discriminant of 0. So, because there needs to be just one intersection point, right? So now what I'm going to do is, how do I make the discriminant equal to 0? Well, the discriminant is equal to 0 when b squared minus 4ac is equal to 0. And we know numbers that go into b squared, b, a, and c up to a certain point. And let's see what that means. So we're going to put 4 plus m in for b, because the b coefficient is multiplied times x. So, and then the a coefficient is 1 because there's nothing there, and the c coefficient is 4. So, and we set that equal to 0. So now we expand this so that we can combine the terms. So we're going to have 16 plus 8m plus m squared. And now we're going to have minus 16. And so the 16s actually cancel out. That was convenient. So now we have 8m plus m squared. We're going to factor this. So we're going to have 8 plus m here times m. And that is equal to 0. So the two values of m which make this true would be m equals 0 and m equals negative 8. Those are the two possible values that would make the discriminant equal to 0 and make this true. So I think those are the answers we were looking for. Okay, they wanted the values of m. Alright, let's move on to 7a. For what values of c do the lines x plus c never meet the parabola with the equation 2x squared minus 3x minus 7? So we got a red parabola, and we have a blue line, and it's asking us, do you see how the blue line, they don't tell us exactly what c is equal to. They want us to figure out what c equals to, and the hint is that x plus c does not ever intersect the parabola. Okay, so maybe you don't understand exactly what to do yet, but in the case of an intersection, you always want to start by setting the red parabola equal to the blue line because they're going to share the same x or the y coordinate, right? So like for example here, we're going to say, oh, well the y coordinates for both of these are the same, right? And the x coordinates for these are also the same. We just don't know what they are yet. So we set them equal to each other, and then we're going to combine like terms. We're going to move everything to the left and leave 0 on the right. So we're going to subtract x. We're going to subtract x from both sides. We're going to subtract c from both sides. And then we're going to get 2x squared minus 4x minus 7 plus c. And the right-hand side is going to equal 0. So in this case, what kind of discriminant do we want? Well, it says never meets the parabola. So that would be the purple parabola should not touch the x-axis. So the discriminant should be less than 0. So now we're going to say, okay, the discriminant is b squared, which is negative 4 squared minus 4 times a times c, which is negative 7 plus c. So 7 plus c, negative. And then we're going to say, okay, what value of c, oh, I'm sorry, we want it to be less than 0, not equal to 0, because we want it to never intersect. So we're going to put here 16 plus 8 times 7 plus c is less than 0. We're going to multiply the 8 out, so we're going to get 16 plus 56 plus 8c, which is equal to 72 plus 8c is less than 0. So I'm going to save some space here. Okay. And so I'm going to have 72. I'm going to add 8c to both sides. I'm going to subtract 8c. I'm going to subtract 72 from both sides. And so I'm going to get 8c is less than negative 72. And then I'm going to divide both sides by 8, and I'll get c is less than negative 9. Okay? So those are the values of c, which means the parabola, or the line, will never meet the parabola. Choose one of the values of c found in part A above. Sketch the graphs using technology to illustrate that these curves really never meet. Okay, so that's a good test. Let's take, like, c is less than negative 9, so let's put, like, c is negative 10, or negative maybe 12, okay? So we're going to say c is negative 12, and then we're going to put that into the original equation. So the red equation, remember, is 2x squared minus 3x minus 7. The blue equation, now that we substitute in c equals negative 12, is going to be y equals x minus 12. Now we're going to prove using technology that that really works, that they do not intersect. So we're going to take y equals, and then we're going to put in the equation x squared or it's 2x squared actually. So I do second insert 2, and then I'm going to put 2x squared minus 3x minus 7, and then here we're going to put x minus 9, because at x minus 9 it should just exactly touch the two curves. The curve and the line should exactly touch. Yep, tangent line. See that? Okay. So that was B. Now we'll go on to 1F. Problem solving with quadratics. Okay, they give us a few examples in the book, which are good to read if you have a chance. They're giving us word problems here. So they want us to find numbers that have certain characteristics. So for number 1, for example, they want us to find two integers that differ by 12 and the sum of their squares is 74. Okay, so let's say that one of the integers is a and the other integer is b. So we have two integers and they differ by 12. So a minus b is 12. The sum of their squares is 74. So a squared plus b squared is 74. So we got two equations here. Then it tells us to find the integers. So we have two equations and two unknowns. You've done problems like this with linear equations. Now this is pretty much the same. I'm going to use the substitution method, and so I solve for one of the two variables. It's kind of convenient to solve for a, so I solve for a. A is equal to 12 plus b. Now I'm going to take the 12 plus b and I'm going to substitute it in for the a squared. So that'll give me 12 plus b squared, 12 plus b, quantity squared, plus b squared. Okay, and that's equal to 74. Okay, so if we can find the b that satisfies that, then we will know one of the numbers, and then we can find a easily. Let's do this on the calculator, because if you get a problem like this, this is in the calculator section. So all we need to do is type this equation in, and then see when it equals 74. Or we could subtract both sides, 74 from both sides, and then we'll have 12 plus b, quantity squared, plus b squared, minus 74 equals 0. And then we'll see when does this equal 0. Okay, so let's do that. So we'll do y equals, and we'll put parentheses 12 plus b. Instead of b, we're going to put an x, because with the calculator it always has to be x. Squared, and then we'll put plus x squared, and then we'll put minus 74. Minus 74, and then we'll delete this one down here. And then we're going to graph it, which should be a parabola. Yeah, it is. And then we just want to know, okay, when does the parabola intersect here? So to find the intersections, we just do second calc, and then there's a function called zeros. So the way zeros work is you move the cursor so that it's on the left side of the place you're intersecting, like there, okay? Then it says right bound, and you move the cursor to the right side of where it's intersecting, like there. And then we're going to find the intersection right there, right at this cursor. So it wants us to guess, say, yeah, that guess is fine. And so one of the possible intersections is -7, 0. So let's say b is equal to -7, for example. And then to find the a value, we could use the original equation here. So a is equal to 12 plus b, so a is equal to 12 minus 7, which is a equals 5. Okay, so that's one pair. There's actually another pair. What about this other intersection here? Let's find that. We'll do second calc 0. And we'll find, let's see, we'll put on the left side of this intersection here, and then the right side of that intersection there, and then we'll guess. And so the other one is -5, 0. So the other solution would be b equals negative 5, and then the a value would be 12 plus b, or 12 minus 7, which is 5. 12 plus b, which is 12, 12 minus 5, which is 7. Okay. So the two possible pairs of number are negative 7 and 5, and negative 5 and 7. Those integers both differ by 7, and the sum of their squares is 74. Okay? So that is 1F, number 1. And now let's move on. So number 3. The sum of a natural number and its square is 210. Find the number. Okay, so we got a number. A natural number just means it's basically a whole number that's positive. So the sum of a natural number and its square, so a and a squared, is 210. What's the number? Okay, so you can see that this is going to turn into a quadratic too. We're going to move everything to the left side, and then we're going to set it equal to 0, because, or it's going to be 0 because we moved everything to the left side. Now, in this case, we could just use poly-SMLT to find the roots, okay? So we're going to insert the 1s there so we can obviously see that the a value and the b value are both b, and the c value is negative 210. So we're going to push apps and poly-SMLT, and we hit enter, and we're going to do poly-root finder, order 2, press next, and we're going to put in a2 of 1, a1 of 1, and a0 of negative 210. Solve. And the two possible roots are negative 15 and 14. Negative 15 and 14. So there's negative 15 and 14. So those are the two possible answers. But since it says a natural number, then we know it can't be negative 15. It has to be 14. Okay, so 14 plus 14 squared, I guess, is equal to 210, which is what we just discovered. Number 5. The product of two consecutive odd numbers is 255. Find the numbers. Okay, so we basically have a plus a plus 2, because two consecutive odd numbers can be represented by the a variable and the a plus 2 variable, right? Their product. So their product is 255. Find the numbers. So again, this is going to turn into a quadratic. A squared plus 2a minus 255 equals 0. So we could put this into poly-SMLT, right? A is 1, b is 2, c is negative 255. Let's do it again. Main, poly-root finder, next. So we're going to put 1, 2, oops, the first one's 1, a is 1, b is 2, and a0, which is c, is negative 255. Now we're going to solve. And the two answers are negative 17 and 15. Okay. So the two possibilities are negative 17 and negative 17 plus 2, which is negative 15. The other possibility is 15 plus 2, which is 17. So that makes sense, right? That negative 15 and negative 17 would be a possible pair, and 15, 17, another pair. All right, last one. The length of a rectangle is 4 centimeters longer than its width. So the length of a rectangle is 4 centimeters longer than the width. The rectangle has an area of 26. So length times width equals 26. Find its width. Okay. So again, we have two equations and two unknowns. We're going to use substitution. We're going to take the 4 plus w and we're going to substitute it in for L. So that will give us 4 plus w times w equals 26. Okay, and then now we're going to make it into a quadratic. So it's 4w plus w squared minus 26 equals 0. Move everything to the left side. Makes it easier for the calculator to figure it out. we're going to order it like we traditionally do, with w squared first, 4w second, and then minus 26 equals 0. So we can see now that our coefficients are 1, 4, and negative 26. So we're going to use poly-SMLT again. Poly-SMLT is a little bit faster than using second count 0, although it's less visual. Okay? So we have 1 and 4 and negative 26. And those are awful numbers. So we got W equals negative 7.48, and we also have it equal to 3.48. Okay, so can the length of a rectangle be negative? No, it can't, so that's not a solution. So the width would be 3.48, and the length would be 4 plus 3.48, 7.48. Okay? Now let's just make sure that multiplying those together does indeed give us the area of 26. So we're going to put 3.48 times 7.48. And yeah, that's pretty close. It does give us 26. Okay, so those are the width and length that we were looking for. And that's it for page 16.